Here's the extra credit for the pH fakie. So we want the pH, and here's the thing, though. This gets a little tricky. We're going to add an acid and a base. So this is going to give off H pluses. This is going to give off OH minuses, and those are going to be kind of in competition. And here's my example. If we had 7 OH minuses and 5 H pluses, well, one of these would grab one of those and make one water. So 5 of these are going to grab 5 of those and make 5 waters, which leaves 2 OH minuses unused and left over. So what you can do is say big minus small uses up all the small number and leaves the rest of the larger number. So we could do, it always makes water, and what's going to be left over? 7 minus 5. And what's the thing that's left over? Well, whatever had the most at the start. So what I'm going to do here is also, so what I'm going to do here is find the moles of H plus and OH minus, and this might be a little bit of a new thing, but watch this. Molarity is moles per liter. So how about we write this out that way so it's more obvious? And when I multiply that by liters, because this turns into liters, the liters cancel out and I get moles. So this times this is that number, and the unit then is moles, and this is moles of H plus. Also, I should point out, remember, we said we're only going to use. Also, I'll point out that I said we're only going to use strong acids and strong bases, and the reason that they are strong, so to speak, is that when you put them in water, they come apart. They all come apart. So all the H's come off this and all the OH minuses come off of this. So to be extra picky, I found the moles of HCl, but that is the moles of H plus, because if you had 10 of these, you would get 10 H pluses. If you had 59 of these, you would have 59 H pluses. And I don't care about the Cl minuses because they won't matter for this problem. And so I can just take the moles of this and call it moles of H plus, and I can take the moles of this and call it moles of OH minus. And I'm going to pull the same trick, so to speak, here. I'm going to take the molarity, because it's moles per liter, and multiply it by the liters, and the liters cancel out, and I get this many moles. So this number is smaller than that number. So this number of OH minuses will use up the same number of H pluses and turn them into water. And I don't care about how many are turned into water. I care about what's left over, because that will change the pH. So when I do subtraction, I do big minus small. Now this time the big happens to be on the top. Maybe it's not next time though, but it's big minus small. It is not top minus bottom. It's big minus small. And this time it just so happens that I chose the top number to be the big number just by accident, really. And so this is what I get for the amount left over. Because what am I looking for? pH. What do I need for pH? H plus molarity. What's inside molarity? Moles. So this is the moles left over. Also for molarity, though, I need liters, and the extra mistake to make here is to just grab the big number and put it under there. But really, if you add two solutions together, their volumes, the milliliters of each of them add up. So what we're going to do is take this milliliters plus that milliliters, get 330, and then change that into liters here. Then we can do moles per liter is molarity of H plus, because we had moles of H plus, wasn't it? Molarity of H plus, and pH is negative log of that answer. For 21, it's somewhat the same idea, except we're adding an acid and an acid. And so we're adding H plus and H plus, so they don't cancel each other out. They just add up. Now, I was explaining to another class, we're going to cheat a little bit here because this has two H's. The first one definitely comes off, and the second one comes off somewhat. And I'm just blatantly cheating, and this one really is a cheat. Okay, so I'm admitting it. We're going to pretend that only one of them comes off, because otherwise it becomes a real math nightmare. And I don't want to get into it. And believe me, you don't want to get into it. So we're just going to say one H comes off of this one, and obviously only one comes off of that one. So I'm going to take this grams, find the molar mass of that, all of it, not just the H, convert it to moles. And we said for every one of these, we'll pretend that only one H plus comes off. So if I had 1 mole of this, I'd get 1 mole of H plus. If I had 3.5 moles of this, I'd have 3.5 moles of H plus. So we can just borrow that number for the moles of the whole thing and call it the moles of H plus. And then I'm going to do the same thing for the moles of the nitric acid. And the H pluses just add up. And now I have moles of H plus because nothing cancels out. It's not like this one. And that moles is over the total liters. And we get a molarity, which is pH by negative log of that number. For 24 and 25, I had a long discussion with some of the math teachers and Mrs. McCurdy, and discovered I think that question is invalid. I am going to skip them. It's a long, convoluted answer. If you want to know, you can ask me. So we want the pH, but we know the OH minus molarity. Well, there are a few ways to do this, but one of them is, how about I find the POH? Because I know that if I have the POH, 14 minus the one I have is the other one. So what I'm going to do is take negative log of the molarity, and that gives me POH. And remember that when you're using the OH minus molarity, you get POH. And then 14 minus the one you know, POH, is the other one, pH. And is it an acid or a base? This is basic because the pH is greater than 7. Again, I have the molarity of OH minus, and they want the concentration of hydronium ion. Now, I'm going to show you another note to self thing for you college chemistry class headed kids. Another thing is that H plus times OH minus will equal 1 times 10 to the negative 14. That means if you know one of them, you can divide it under and get the one you don't know. So that's what I'm going to do here. I know OH minus molarity, so I'm going to put that value under the answer. By the way, this is sometimes called so I'm going to take the value of the one I do know, OH minus, and divide it under 1 times 10 to the negative 14. And that will give me the other one. That will give me the molarity of H plus. Now, they didn't ask it, but I will note that this is a pH I can do in my head. It's pH 8. And that is basic because pH is above 7. Or you could say that the H plus molarity is below 1 times 10 to the negative 7. And if you want to explore that more with me, just ask. What's the concentration of the hydrogen ions in a solution if pOH is 3.5? Well, I think this is the easy way to do this. Say 14 minus the one I know is the other one. And remember, when you have pH or pOH, what you really have is the exponent on 10, except the sign is wrong. So I'm going to put the sign back on, the negative sign back on, and use it as the exponent on 10. And that will get me running the math backward, and it will give me the molarity of H plus. This next part isn't so deep, but remember the calcium is a +2. You can look on your periodic table, which means it would combine with 2 OH minuses. Aluminum is a +3, so it would take 3 of them. NH4, ammonium, and I know that sounds like an element, and maybe you've forgotten, but that's actually NH4. And for all you AP or college class headed kids, maybe and for all you AP or college headed kids, you might sock away in the corner of your brain that is ammonium, NH4 +1, which is why it combines with one OH minus. And lithium hydroxide, well, would be one of each because lithium is a positive one. Look at your periodic table. Then I decided I would get a little nerdy on this and remind us how to name acids. If you don't care, then don't watch. Hydrochloric, and we said hydroblankic acid uses only one element on H. So hydrochloric acid has only one H on. So hydrochloric acid has one element on H. And of course, we know it's chlorine. And if chlorine is a -1, then it can take one H on it. Nitric acid is different though. Notice it does not say hydro in front. Therefore, it is not one element. It is a group that is on H. And here's our acid naming. Ic acid comes from 8. So if it's nitric acid, it uses nitrate. And nitrate is NO3 -1. So let's throw as many H's as we can get to stick on NO3 -1. And of course, that's one of them because H is +1. Sulfuric acid runs the same way. Sulfuric acid comes from sulfate. I understand that the R is missing in there. That's just the way it goes. Sorry. It's not sulfurate. I know it sounds like it should be. So sulfuric acid comes from sulfate, and sulfate is SO4 -2. So there would be two H pluses that stick to SO4 to make sulfuric acid. And for D, we get even more slightly complicated. For D, we get slightly even more complicated. Perchloric acid. So we have perchloric acid would use perchlorate. Well, I know somebody will say, well, I don't have perchlorate up here. Right, but you have chlorate. And perchlorate sounds a lot like it. In fact, there's another naming box down here that perchlorate would be one more oxygen than regular old chlorate. So if chlorate is ClO3 -1, perchlorate is ClO4 -1. And then we're going to make an acid out of it by sticking H's on it. So ClO4 -1, and it would only stick to one H plus. And hydrobromic would be HBr because hydro means just bromine and then H's. And bromine is -1, so it can only handle sticking to one H plus.